All right, so now I'm going to go through the whole process kind of in one big movement here. And I'm going to use a slightly bigger number just to review the process. So we start with the number itself and the factored tree. Again, it's an even number, so I usually like to start with a 2 because I know that all even numbers can be divided by 2. Plus, 2 is a prime number, so that gives me an end to this branch here. I circle it, and that is not going to go any further. Now, what number multiplies by 2 to equal 24? Another way to think of that would be, well, what's 24 divided by 2? Okay, using the times table or mental math, you can figure out that 2 times 12 is 24. All right? 12 is not a prime number. It has other factors, so we need to break it down further into primes. Is 12 an even number? Yes, it is. So I know that it needs 2 more branches, and I'm going to, again, use 2 on this side. 2 is a prime number. I'm circling it. That branch is finished. Which number can be multiplied by 2 to equal 12? 6 can. All right, 2 times 6 equals 12, but 6 is not a prime either. I can't leave it like this. I need to go one step further. So I need 2 more branches, and I need 2 numbers I can multiply together to equal 6. Well, it is an even number, so I know that it can be divided by 2, and I also know that 2 times 3 equals 6. Now at the bottom of every branch, I have prime numbers and there's nowhere else to go. I can't go any further with this. That's good news. So now, like I showed you before, I bring these prime numbers back up here and I write it out in expanded form. So I had 2 times 2 times 2, because I've got 3 2's, and then I put times 3. And what does that equal? Well, 2 times 2 is 4, times 2 is 8, times 3 is 24. That's good news. We want to see that the prime factors can multiply together to equal the number we started with. Or I would write out my primes as powers using exponents. So now I'm going to start with a base of 2, and I have to count how many do I have. 1, 2, 3. So that's 2 to the power of 3, okay, times 3, and there's only one of those, 3 to the power of 1. All right, and now we wanted to determine the number of factors next. This is where I'm going to bring down my exponents, and I'm going to add 1 to each one. So if 2 to the power of 3, if I bring down this 3 and I add 1 to it, I get a 4. And if I bring down this 1 here and I add 1 to it, I get a 2. 4 times 2 equals 8. 8 is going to be the number of factors that the number 24 has, which is super important because now I know how many pairs there will be. If there are 8 factors, there should be 4 pairs. So that's 4 arches in the factor rainbow. So I'm going to draw 8 circles down here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, got my 8 circles. First step, as I showed you before, is always to start with 1 and the number itself on the far end, the number 24. So that's going to be the first arc in the rainbow. 1 times 24 will equal 24. Okay, next, what do? Well, I move through my factor tree again and I look for numbers I can make. I look for factors I can make by multiplying different combinations of prime numbers together. So, do I see a 2 represented? Absolutely. If I block off all the factors other than 2, then 2 is left. I know that 2 is a factor of 24. Okay, so 2 times some other number will equal 24. You probably know what it is already, but we're just going to do this the long way. Next, do I see 3 represented? Absolutely. If I ignore those other numbers, I see 3. 3 is going to be a factor. How about 4? Absolutely 4. Because if I block off all the other numbers in the factor tree and I see 2 2s, I know that 2 times 2 is 4. So 4 is going to be a factor of 24. So 4 times some other number will equal 24. So I look here again, there's no 5. 5 is a prime. 5 would be on here and it would be circled if it was a factor. It is not. But how about 6? I see 6 in my factor tree and I know that 2 times 3 equals 6. So yes, 6 is the next factor. How about 7? Absolutely not. 7 is a prime. It would be up here somewhere and it would be circled if it was a factor. It's not. How about 8? Can I multiply together any combination of these numbers to equal 8? You betcha. If I block off these numbers, anytime you have 3 2's in your factor tree, 2 times 2 is 4, times 2 is 8. You can make the number 8. So that's the next factor. How about 9? Can I multiply any of these together to make 9? No, I would need another 3, so I can't do that. 10, not a chance. Nope, because 24 would have to end with 0 to be divisible by 10. So now we want to see how can we make this other number. Well, it's not going to be 11 because 11's a prime and it would be in the tree. Now, if I just block off one of the 2's, I have 3 times 2, which is 6, times 2, and that gives us 12. And that's the last factor we're looking for. Factor rainbow complete, prime factorization complete, number of factors, and factor tree complete. All right? So I want you to try and follow this process with some bigger numbers that I give you, and we'll see how you do with that. All right.